Hi everybody. So hopefully by this point you've realized that the nice thing about videos is you can fast forward them if you're finding they're too long, and then just get to what you need to get your information you need. Because I mean, think about it, that's kind of how we normally do things anyway. So let's take a look at a few more examples of looking at these relationships and discovering whether or not they're proportional. So most of the time when we're trying to figure out if something's proportional, we usually know whether or not it's linear, okay? And then our other criterion that we look for is, so the big things we're looking for proportionality, right? So proportional, the things we're looking for is it linear? So it's got to check that box. And it also has to go through the origin, right? So those are the two things. All right, so in this problem here, they're asking us to do a couple things. So the first thing they're doing is they're saying find the constant rate of change and interpret its meaning. Well, I know this is going to have a constant rate of change because it's linear. All right, so if it's linear, it has to have a constant rate of change. So all you got to do for that is just basically find 2 points. So let's take that point. Let's figure out what it is. So that is the point. It looks like it goes up to 3 and then 60. All right. And then my next set of points, let's use another color, is, let's see, it looks like it is, sorry, you can't really see that, but I'm going to write it anyway, is 6 and then 30. All right, so good. So we've got 2 sets of points, and so to figure out our constant rate of change, as we just look at, well, what's happening? Well, let's look at our y first. So it looks like going from left to right, and this is always a left to right kind of thing. It looks like from 60 to 30, it is going down 30. All right, so we're going down 30. I'm going to write CROC equals, it's going down 30. Down would be marked as negative in this case. And then it looks like it's going up 3. All right, so over plus 3. So I have 30 divided by 3, which is 10. And you have a negative divided by a positive, which is negative. So my constant rate of change is negative 10. So I'm going to rewrite this as negative 10. And it looks like it would be feet per second. And what the meaning is, all right, so I'm going to write that down, right? Negative 10 feet per second. And what it means is the hawk is diving down at 10 feet per second. A lot of times when you're talking about velocity and things like that, the negatives and the positives basically indicate direction. And you'll discover that when you take physics later on. All right, now, determine whether a proportional linear relationship exists between the 2 quantities shown in the graph. Explain your reasoning. Well, it's got a tick. We're going to go up and we're going to look at, does this tick our boxes? All right, so is it linear? Yes, it's linear because it has a constant rate of change. So that's good. And it makes a straight line, which we can see here on the graph. So we're good. But does it go through the origin? No, it doesn't go through the origin. The origin's right here. And this line is a very nice line, but it never goes through that origin. So for your answer, you would say, I don't want to do green. I don't know why I always pick green. Let's do purple. I would say no. All right, I would say it is linear, but does not go through the origin. All right, let's look at one more example. All right, so right away this is already looking better. You can tell it's linear, right? And you can tell that, hey, that might work for us, right? So anyway, we're getting ahead of ourselves, but that's all right. So it says, find the constant rate of change. So we're at an A right here. Find the constant rate of change and interpret its meaning. All right, so let's see what our points are. So this point right here is the point 6, 2000. I'm just looking at, where it is right here, right? And this one looks like the point 3 comma 1000. All right, so for your constant rate of change, it's always going to be how much does your y change over how much does your x change. That delta is just a symbol for change. That means change. All right, so the y looks like from left to right. All right, so from this one to this one, the y looks like it goes up 1000. And you can tell it goes up because look at your line. Your line goes up from left to right. And then your x goes up too from 3 to 6, so it goes up 3. So this is going to give you a constant rate of change of 333.33, all right, and then per day, right? So you are selling $333.33 per day. So this is kind of a weird example, but that's what it means. So selling 333.33 per day. Okay, determine whether a proportional linear relationship exists between the two quantities shown in the graph. So remember, let's go back and let's look at our chart here. Well, it's got to be linear, and it's got to go through the origin. So if I go and I look at this example, is it linear? Yes. Does it go through the origin? Yes. So it ticks both of those boxes. So therefore, it is indeed proportional. It is proportional. It is linear and goes through the origin. And you're in good shape. All right, thanks.